vertical and horizontal shifts of graphs. So a vertical shift of a graph moves the graph up or down. So when you think of a function, y equals f of x, that's our typical function. When we want to do a vertical shift to it, it's going to happen on the outside of the function, so plus and minus c. Where y equals f of x plus c moves it up, y equals f of x minus c moves it down. In general, I like to say anything on the outside of the function affects the y values, and you follow what it tells you to do. If it says plus, you go up. If it says minus, you go down. So for example, over here, they give an equation for each function that's graphed. So we got to know the parent function, which is absolute value of x, and that happens at the origin. So that's what normal absolute value graph kind of looks like. And this one just been moved down to. So this equation would be y equals absolute value of x minus 2 on the outside. So we went down, so on the outside you go minus 2. This should be down here. Okay, there we go. And then this one, it's the same graph, absolute value graph, but moved up 1. So we're going to do y equals absolute value of x. Then we go to plus 1 on the outside. Because that plus 1 on the outside lets us now move it up 1. That's how you do vertical shifts, up and down. Horizontal shifts move the graph left and right. They happen on the inside, as you can see here and here. So when you see something like this, so what's on the inside tells you to move left or right. So I always like to say inside x, and you do the opposite what it says. So over here, you see how it's x is equal to 0, and there's a minus b. So you move the opposite, you move a plus b this direction. So it's inside opposite. So whatever's on the inside, you do the opposite what it says. So likewise here, you have the absolute value of x, which is this graph. And then we want you to write the equation for these two things. So this first one, it's moved to the right 4. So that's going to be, again, anytime it moves left and right, it's on the inside. Inside for absolute value is inside the parentheses, or the absolute value signs, I should say. And we do the opposite. So this went to the right 4, or plus 4. Rewrite the opposite, minus 4. This one right here, again, we moved left and right, so it's on the inside. So we do the opposite. So we went left 2, we get the right plus 2 inside. And that's how you write these things. And then we can combine them. So we're going to combine vertical and horizontal shifts. You just do both of them. It doesn't really matter which order you do. It's like order operations. Plus or minus doesn't matter which one goes first. So this first one here, we're actually going to graph for once. So we're going to graph this guy. So it's an absolute value graph. I know the basic one looks like this. I'll do a dotted line here. And then, so my general rule here with how we do shifts is inside x opposite, outside y follow. So anything on the inside affects the x-axis, you want to do the opposite. So it says plus, you go minus, minus, you go plus. And then on the outside, it affects the y value, so you follow. Now remember, x is like, let's shorthand for saying left and right. Y is going up or down, right? Because x-axis is going left and right. Y-axis goes up and down. So a lot of times you can think about this as your starting point. So, right, like we have a point here, an xy point. So where I want to start, normally start at 0, 0. But on this one it says on the inside, you want to move inside affects my x, you do the opposite, so it's minus 2. And the outside, you follow what it says. So my y is being negative 6. So that's my graph moving. I'm moving from 0, 0 to, I'm going to go left 2 and down 6. So right there, and then you do the exact same graph. So inside effect. So look at this one, right? I'm going to do the basic one first, so we all see what it normally looks like. And then this one, we're going to move right 2 and up 8. Inside opposite, outside follow. See, if you want to think about it this way, you start at inside opposite 2, right? Inside is my x, and you do opposite 2, and outside is your y, and you follow 8. So we'll start at 2, 8. It's the exact same graph. Something to that effect. Write an equation in x and y that results in desired translation. So this one says the cubing function shifted 2 units upward. So the cubing function is x cubed, and we want to shifted upward. So this is going to be on the outside. So we're just going to do like f of x equals x cubed plus 2. Right? Outside, up and down is the y values, and the outside y follows, so plus 2. The cube root function should fit 6 units upwards. Oh, downwards. I messed the last one up. It should be down 2. There we go. Sorry about that. Downward, so minus 2. The next one, the cube root function, so x cube root like that, should do 6 units upward. So this one we're going to go plus 6 on the outside. So it'll be f of x equals cube root of x plus 6 on the outside. Remember, so anything moves up or down is on the outside. The absolute value function shifted 3 units to the left. The next one is absolute value function, looks like this. 3 units to the left. So this is going to be on the inside. Now remember, inside it's opposite. So left would normally be negative 3. But we do the opposite. We're going to do plus 3. It's like solving the equation. So again, shift 3 units to the left, so that'll be negative 3. But again, when you plug it in, you do inside x opposite. So that's why it's plus 3. And on the inside. Next one, the square rooting function. Let's change the color first. So the square rooting function, that means x squared, I believe. Shifted 4 units up, so plus 4 on the outside. And 1 unit to the left. So that's again minus 1, but inside opposite, so it's actually a plus 1 on the inside. Right, so we're going to have our squaring function, f of x equals something squared. So that's our squaring function. We're going to shift it 4 units up. So remember, up and down is on the outside, and you just follow what it says. And then left and right's on the inside, you do the opposite. So 1 to the left would be a minus 1, but we do the opposite, so x plus 1. And notice how my square is outside the parentheses here. Some people put the square right here. That's wrong. Outside. You want your plus 1 to be on the inside. Absolute value function shifted 1 unit downward and 5 units to the right. So absolute value function looks like this. 1 unit downward, so we're going to go on the outside, we're going to put minus 1. And 5 units to the right. So remember, to the right means like generally plus 5, but inside opposite, we're going to go negative 5 on the inside. So my equation looks something like this. X minus 5 on the inside, plus, minus 1, sorry. Minus 1 on the outside. That's right. So this thing would be shifted 1 unit downward, outside, and then 5 units to the right, inside opposite. So that'd be plus 5 and you move to the right. For each of these, we want to match the group. So look at this one. Square root of x plus 4. So move the graph up 4. That it would just be the first one. That's A. Second one, y equals x plus 4 minus 3. So remember, the next way to think about this is like, where do you start? So inside opposite, so negative 4. Outside follow negative 3. So we want to start at negative 4 and negative 3, which would also be that one. just B. Okay, this is not exciting. And then this one, again, you can think about it the same way, inside opposite, so plus 4. Outside follow minus 3. So right 4, down 3. There we go. See? That was the least interesting. I just picked these at random. That's the least interesting one. Use translations of the basic functions, so you can see the basic functions here, to sketch these by hand. So you want to sketch these by hand. So kind of like we did earlier in the example. So this is to show you guys, you don't have to do this. I'm gonna show the basic x cube graph. That looks like this. That's what a basic x cube graph looks like. And then we want to do whatever shift we have to do for this one. So this one, it's on the outside, right? So that's on the outside, which affects the y value, and you want to follow what it tells you to do. So we're going to go plus 1. Right there, and then we just graph the same function. So something to that effect. Next one. Again, I'm going to do the same thing. I'm going to graph the basic one, just so we know what we're dealing with. That's what an x cube graph looks like. Now this has the plus 1 on the inside. So remember, inside is x, and you do the opposite. And x is short for moving left and right. So this one, if you do the opposite, it's the plus 1. We'll move it 1 to the right. Then we do the exact same graph. It's inside effect. 50. Square root graph. So let me draw a basic one so we know what the graph looks like. Something like that. And And then we're going to do two things. We'll move it left and down. So you always think about it as like, where do you start? Inside opposite, so I should start at -3. Outside follow, so -4. Right? Or you can think about it as let's move left 3 and down 4. Either way works. So like that, and then just grab the square root function. So something to that effect. Given the function shown below, I guess first to the right, sketch the graph of the desired. So this is an important concept. So it's the same concept as the one we just did, but now instead of having like a predetermined graph we know about, like square root or x cubed, they're going to give you a graph. Like, here's this random function here. I want you to do this to it. So like for me, it's like the most pure assessment of the topic. So look at the first one here. Here's our f of x. Oops. And what we want to do is we want to get f of x and go +2 with it. So whatever x is, +2. So how do we do this? Well, first we got to tell, wait, this is on the outside. So it affects the y values, and we're going to go +2 or up 2. So you get to all the y values and go up 2. So move it up 2, move it up 2, move it up 2. Or if you want, you could just get the points and just add 2 to all the y values. That's what that's doing. It's doing that's what it means. Right, f of x +2, that affects the y values. It's on the outside, you follow what it says. So we can just add 2 to all the y values. And we get 1, 1. We get 2, 5. And we get 4, 5. And if we connect those dots, we get the picture we want. So we get that. So again, it works either way. You can go, okay, here's my function, and I move every point up 2. I went a little far on the 4, 5, and I realized I went a little too far. There we go. So it looks something to that effect. Right, so it looks like you just shifted up 2. All you had to do there was add 2 to all the y values. Okay, next one. I'm just going to use the same graph because it's a little easier for me. And I use the same points. Maybe I'll do this. That picture looked kind of like this. The normal one looked like this, and the one I drew looks like this. Okay, next one. So we're doing that one. Now again, it's also on the outside. So it's on the outside, so it affects the y values, and you follow. So -2. So we're going to go -2 to all the y values. Because remember, outside affects only the y's, and you follow what it says. So you could go here and move everything down 2. Or you could just go -2 to all the y values. If you do that, you get 1, -3, 2, 1, and 4, 1. So our graph looks like this: 1, -3, 2, 1, and 4, 1. So it looks like that. I mean, besides my bad drawing, do you see how everything's kind of moved down to? That's all it does. It moves everything down to. So, okay, I'm going to erase it all in a second, but just to give the idea what it did. So, I mean, that's not the best picture. Something like that, though. Okay, next one. It's a little more interesting. So this one's on the inside. Inside affects the x values, and you do the opposite. So we're going to go -2. So you can move everything left 2. So just move all the points left 2. Or, like I've been saying, this affects the x value, so on your x values, just subtract 2. And you get -1, -1, 0, 3, and 2, 3. So -1, -1, 0, 3, and 2, 3. And you get a graph looks like that. Right? Like it shifted everything over left 2. And then the final one. Inside x opposite. So this one we're going to go +2. So we're going to move everything to the right 2. Or just add 2 to all your x values. So +2, +2, +2. You get 3, -1, 4, 3, and 5, 3. So 3, -1, 4, 3, and 5, 3. 6, 3, 6, 3. You get something like that. right? So it looks like that graph's been moved over right too. So that's one way to do it. You just get, anytime you see these shifts, you just get your points, and then just either add stuff to your x value, your y values, or add stuff to your x values. It works the same way. Effects of shifts on domain and range. Determine the domain and range of the shift graphs. So this one right here, I mean, I guess it makes more sense if you knew the basic parabola. It looks like this. My domain here would be negative infinity, positive infinity. My range would be 0 to infinity. Now look at my shift graph. The domain, different color, is still negative infinity, positive infinity. But I move my graph up 2, so look where the lowest it starts at. There's a shift of 2, so now I start at 2. So 2 to infinity. It didn't affect the domain because my domain was already negative infinity, positive infinity, so it's not going to change that. But since my range actually had like a limit, 0 to infinity, when I moved it up to, it changes the range. Right? Anytime I move it up or down, it's going to change the range. The next graph doesn't change anything. My domain is negative infinity, positive infinity. And my range is negative infinity, positive infinity. So nothing changed there, no matter which way you do it. This one, again, let's look at the basic one before we do anything. My domain is 0 to infinity. My range is also 0 to infinity. So that's the range of a normal function. Now if I shift it, it looks like we went right 2, down 3. My domain now is, well, it starts at 2 because you shifted it right 2. So it starts at 2, so it goes from 2 to infinity. And my range, well, we shifted down 3, so my range went down 3. Negative 3 to infinity. It's like that. So in general, like if your domain is already negative infinity, positive infinity, it's not going to change any of it. Moving it left to right won't change it. But if your range or domain has a specific value, when you change one of them, it will change the domain and range to whatever that thing you shifted it toward. Okay, I think the last thing with that graphic, I can determine the domain and range of these functions. There's a couple ways to do it. For me, the easiest way is always just to graph it. We should know how to graph these basic ones. So this is a square root graph, but we're moving it inside opposites. We're moving it to 4. Outside, there's nothing there, so we start at 0. So it looks like this. So my domain will be 4 to infinity, and my range will be 0 to infinity. My domain's farthest left, which is 0, so where we start, all the way to infinity. My range, lowest to high, my lowest is 0, all the way to infinity. Again, that's just like the one I did over here, but we shifted our graph right 4. So I move it right 4, my domain changes 4, because domain's the x values. Right, since I moved it to the x 4, change my domain 4, my x. The next one, x cubed. So if you know the cube root graph, the basic one looks like this. The one we have here, we have to move, inside opposite, left 3, left 7, and outside follow down 10. So if you want to think about where you start, it would be at negative 7 and negative 10. So negative 7 and negative 10. And then you do the cubic function. Something to that effect. Now my domain here, lowest I see is arrow, highest I see is arrow. So domain's all row numbers. And my range will be the same thing, lowest I see, arrow, highest I see, arrow. All row numbers. So it doesn't change the domain range anytime it's in negative and positive. It does change it if it is like capped. Anyway, that's the lesson.